Hi, my name is Sylvia, and I'm on Team 11260 Up Creek Robotics.
Hi, my name is Trevor. I'm also on 11260.
And today our presentation is going to be about using OpenCV with the new SDK file. So we have three sections in this slideshow. First, we're going to just do like a little basic rundown of the new Vision Portal. Then we're going to talk about OpenCV, some capabilities of it, what you should use your initialization process for, and then we have some actual applications of it, and then some examples. And then lastly, we're going to talk about how to use multiple processors, how to manage them, use them to communicate between each other, and then how you can actually apply those in your code. And one thing, if you decide to go through these slides yourself, you can click on these and they'll take you exactly to the slide of topic without having to look for it. So the first slide that we have is talking about the new Vision Portal. So the Vision Portal is the new FTC interface that is used for vision processing. The biggest thing that it does is it makes it a lot easier to access TensorFlow and APO tags through the SDK. And it works basically by managing each vision processor with its own individual pipeline. So here we have two links for you. First up is a presentation from a first alumni that does a really good job talking about Vision Portal and also a little bit of its application. And then here are some Google Docs detailing specifically how to integrate it into your code, just like a more detailed instructions for it. So the second section we have is about OpenCV. We're just going to do a breakthrough of its capabilities, its initialization process, the application of it, and then some real examples for how you could potentially use it in your code.
Alright, so start when you're adding the OpenCV capabilities, you'll have to create a new vision processor. So to do this, you create some new public class, and then you implement vision processor and its three main methods with it: init, process frame, and onDraw frame. These are kind of key to really getting it to actually do its stuff, and we'll talk a bit more about them in the next slides. So first, starting with init, this is mainly a method for using for calibration for your camera. However, you can use it for any kind of one-time calculation you want to do right when you start your camera. These things can be important for anything that uses your camera like dimensions or something, or like so if you want to use camera.width or something, that way you can actually take that in and do a calculation with that after you've started it. That way you don't have to make a bunch of specific calculations for each camera resolution you use, and it makes coding a lot cleaner and more efficient if you do your one-time calculations for starting camera in here. Next is process frame. This is the method of the actual processing. Instead of modifying the frame as an incoming from the image, it's really recommended that you make a clone of this, because this frame is actually used in each of the OpenCV processors, which we'll talk about a little later. For the actual modifications of this frame, you can use all sorts of OpenCV processes, and you can learn a lot about these in the OpenCV docs, which is linked here, and you could also find just Googling OpenCV docs. There's a ton of different options here, and you can really get creative and do whatever you want. So the biggest thing, though, is that you take in frame, modify it however you want, and then you can return anything, like any kind of object you can return. So that could be a matrix, a double, anything that you'll find useful for your next method, which we'll talk about a bit more there. onDraw frame, finally, is where you actually try to show the user what they have done. And this basically, you take in user context and a canvas. Those are the two key parts. User context is the object that you returned from the image processor, and this basically means that whatever you put in there, you can now actually use for a change on your image. And we'll get into how you specifically actually change it in the next slide. So for uses of onDraw frame, you basically use paint and the canvas if you want to actually draw something yourself. So to use paint, you create a new object, you can set the parameters you need, and then you can basically add to the canvas and basically use various canvas methods, which you can actually see in the canvas class. If you're using the SDK, you can look through them all. A little note is that they all work in floats. So anytime you're putting in numbers, you just want to convert them to floats if you're working with the canvas. Next is an image just demonstrating how you use user context. And here, you really take in anything as your user context, but if you want to use it as something specific for a specific method from some other element, such as in this case, we're trying to create a bitmap and then write it onto the new image. So for this, we need to basically take the image in as user context and then check that it is a mat. Then once we know it's a mat, we can set it to that. That way we can avoid errors and actually move on to the next steps without an issue. And yeah, this is just a simple example, but again, you can get really creative with all of this, and it's really up to you how you actually end up using these elements.
So our third group of slides are about having multiple processors at the same time, how to manage having them all running, and then how to use communication between them, and then how you can actually apply the use of multiple processors in your actual code.
Okay, so for managing processors, you start by adding a processor, and then you can add multiple processors. And a key note is that the order of these does in fact matter. In this case, the loops would go through AprilTag, backdrop processor, then OpenCV processor. And that's important because your processors, if you modify frame, will modify it for the next processor as well. It'll put in the same image to all of them. So with this knowledge, you can actually do some fun things like calibrating your camera by putting that in the very front and unwarping a fisheye lens camera, for example. And a note is that the AprilTag processor and the TensorFlow processor, you can't actually really change yourself, so you usually want to put those pretty early on in your list of processors. This is important because it allows you to have a little bit more efficient way of managing your processors by being able to enable them and disable them at specific times instead of sticking all of the processing in one loop. And that really just helps to save time and efficiency if you use one for Auton, but you don't really need it in teleop. That way you can disable it and you can still run your web camera at a lower cost. Next is processor communication, and in this, once you have multiple processors, you can actually use information between them. In our case, we're actually using our AprilTag processor as a parameter to one of our vision processors just with OpenCV, and this basically allows us to do some cool little tricks like using the AprilTag locations as more information when we're trying to do our vision processing, but you can really, again, get really creative with it. There's other ways to actually implement the AprilTag processor into other things, or vice versa, by using some higher classes. You have two classes that you're just sending up data to. There's a lot of really cool ways you can do it as you get creative. Finally, here's an example application of doing this. This isn't actually in Java, it's a different coding language that we use, Kotlin. However, I think it still serves as an example. In this case, we are basically taking in the detections of the AprilTag processor and creating a list with a bunch of points from the corners of them. These dimensions allow us to do tons of different processing things with the actual physical plane that we're looking at with the backdrop, and you can do all sorts of cool stuff with this. And yeah, so it's just one example of just taking in and then pulling out data, and then you can use that data for future OpenCV processes.
So that's all for that presentation. Thank you guys so much for watching. If you have any questions, you can send us an email at 11260.ftc@gmail.com, or you can go ahead and send us a DM on Instagram. Our username is team_11260. And here's a QR code and a link to these slides in case you want to look at them yourself. Thank you guys.